Okay, we continue with the last part of chapter 8, which is the binary logistic regression. Okay. Um, okay, so what is the logistic regression? It is the one of the multivariate technique concerning separating distinct set of objects and allocate new object to define the group which called classification. Okay, so it is like the discriminant analysis, but there is a little bit differ from that, which is okay. The discriminant analysis is we can do the discriminant analysis if we have the dependent variable y is categorical, whether it is two groups or more, and the x ataupun independent variables should be, all the variables should be continuous. Okay, but for logistic, the independent variable can be categorical with only two category, okay, ataupun two groups, and the x ataupun independent variable can be mixed between qualitative and quantitative variable. Okay, can mix category and also the continuous scale of measurement untuk independent variable for logistic. So this is the difference between the discriminant analysis and the logistic regression analysis. Okay, but we also can separating the distinct set of object, and we can allocate the new object to define the group, okay, which is called the classification. Okay, sama macam discriminant, kita boleh juga classify the new object ataupun newcomers to go to which group, okay, the first or the second group untuk logistic. Okay, okay, untuk discriminant dia punya y, kategori y tu can be more than two, but untuk logistic, binary logistic regression only two groups ataupun two level. Okay. Okay, like I said just now, logistic regression is an approach to classification where some or all the variable are qualitative. It can be mixed between qualitative dan juga quantitative variable for x. Okay, in short, the response variable y is in binary outcome. Okay, for example, survive or die, purchase or do not purchase, pass or fail. Okay, ada dua level of category. Okay, then we always can code the two cases of y tadi as 0 and 1. For example, 0 for male, 1 for female. Okay, how you can code this variable is up to the researcher, whether you want to make it 0 for female or 1 for male and so on. Okay, the probability of P of 1 is a parameter of interest, which is the probability of that we could as 1. Let's say this, for this example, is female, is the parameter of interest. That is our main concern. Okay, P represents the proportion of the population who are coded 1. Okay, like I said just now. So if you are interested to know about the probability of which group, so that one will be coded as 1. That is your parameter of interest. Okay, so the assumption for logistic regression, okay, the first one, the response variable y must have only two outcome. Okay, only two outcome ataupun dipanggil binary. Dua saja, male or female, survive or die, and so on. Ada dua saja. Okay, the predictor variable, which is the independent variable, may have both qualitative and quantitative variable. The sample size used usually large. There is no multicollinearity between the predictor variables, so we can check first through the box plot ataupun the scatter plot. The error does not need to have normal distribution, so no need for us to check for the normality. Okay, untuk logistic regression. Okay, so one of the important thing in logistic regression adalah odds ratio. When we want to interpret the coefficient of the logistic regression, we will need to find the odds ratio. So what is the odds ratio? It is the ratio of the probability of coded 1 to the probability of coded 0. The value can be greater than 1. The value of odds ratio can be greater than 1. So the formula is P over 1 minus P. So P tadi adalah the probability of when we coded Y as 1. Okay, that is the P. For example, if the probability is 0.8 of person get through customs that their luggage not being checked, okay, is 0.8, the odds ratio will be 0.8 over 0.2 will be 4. Okay, so P adalah probability of interest. Okay, so here dia punya for this example, kita punya variable that we coded 1 is the luggage not being checked. It will be coded as 1. Okay, the luggage being checked will be coded as 0. So because of that, this probability will be P. Okay, the probability of the variable that we are interested to study. Okay, 0.8 over 0.2 will be the odds ratio, will be 4. Therefore, we can say that the ratio 4, 1 of not being checked. Okay. Okay. So when the odds are 1, so the outcomes are equally likely. So maksudnya the probability of getting coded 1 and 0 are equal when we get the odds are 1. Okay, sebab kat sini akan jadi, kalau sama kan, dia akan jadi 0.5 over 0.5 will be 1. The odds will be 1. When the odds are greater than 1, the natural log increases slowly as x increases. When the odds are less than 1, the natural log decreases rapidly as x decreases towards 0. Okay, so actually you can refer your textbook juga. I lupa nak bagi tahu tadi, your textbook in chapter 11. Kalau dalam your textbook is chapter 11. Page, check here. Okay, page 634. So yang ni dia akan ceritakan, it can be described in page 635. Actually, the interpretation of this odds ratio, you also can refer to the figure 11.15. So daripada sini kita boleh tengok dia punya graph. Graph natural log when the odds ratio are greater than 1 and when odds ratio are less than 1. Okay, just illustration of the logistic regression graph. Okay, later I will show you how to interpret the ratio when we have the value. Okay, we will interpret properly. Okay, So next, we want to know how can we build the model of logistic regression. So first of all, you need to know about the logic model. Okay, untuk logistic regression, kita akan gunakan natural log of the odds ratio. Ini dipanggil logic model, which is the ln of P over 1 minus P. Kan tadi P over 1 minus P adalah odds ratio. So the logic model adalah the natural log of the odds ratio. Okay. The logic is a function of the probability. In the simplest model, we assume that the logic graph as a straight line in the predictor variable x. So the function of the logic model will be beta naught plus beta 1 x. Sebab ia adalah straight line. Okay. It is easier for most people to think in terms of the probabilities. So we can convert from the logic or the log out study to the probability P. Okay, to summarize, the logistic curve can be written as this: P equal to exponent power of beta naught plus beta 1x. Okay, if we have only 1x. Okay, divide 1 plus exponent power of beta naught plus beta 1x, or here 1 over 1 plus exponent power of negative beta naught minus beta 1 x, ataupun e power of negative of the this linear line. Okay, straight line. Okay, so macam mana sebenarnya dapat this formula? Sebenarnya dia daripada sini. Okay, daripada sini kan, ln P over 1 minus P equal to beta naught plus beta 1x. Okay, ini actually adalah the logic model ataupun logistic regression model. Okay, so daripada sini, okay, kita dapatkan nilai P. Kita dapatkan P sebagai penyebut dia. So last kali you akan dapat this. Okay, or this one. So we can find the probability when using this formula when we have the value of x and so on. So later I will show you the example how we can use this formula. Okay, this formula kita boleh gunakan untuk dapatkan nilai probability when x equal to what? 0 or 1 and so on. Okay. So we will use that logic model to create the logistic regression model. Okay, so when we have several x, so it will be like this lah: beta naught plus beta 1x1 plus beta 2x2 until beta 1xk. Okay, which is P here adalah probability when y equal to 1. Okay, probability of y equal to 1. Right? Okay. Our y equal to 1 which is our variable of interest tadi. For example, of the logistic regression model, let the response variable y, okay, and the predictor variable x defined as y adalah if a person develop a lung cancer or not, can 0 otherwise not develop the lung cancer. X adalah if the person, if he is smoker, and 0 if he is non-smoker. So sekarang ni we have one dependent variable and we have one independent variable. So actually the logistic regression, the x will be can be several variables. It can be x1, x2 and so on. But for this example, we consider we have only one independent variable, that the independent variable here is also categorical variable. Later I will show you what if actually the x it can be mixed between categorical variable and also the continuous variable, but Y mesti adalah binary, which is the categorical with 2 level of groups. Okay, so we have this. Our interest is to know whether a person develop a lung cancer or not when he is smoker or non-smoker. Okay, kita punya variable of interest adalah one here, which is develop a lung cancer. So the logistic regression will be ln of P over 1 minus P, right, equal to beta naught plus beta 1 x1. So sehingga x1 kan sahaja kat sini because of we only have one independent variable. Okay, so we can estimate beta naught and beta 1. Okay, but usually for logistic regression, we can, for your level, we can create ataupun grab the information to estimate beta naught and beta 1 using the SPSS output. Okay, so odd for the smokers, maksudnya when x equal to 1, okay, the odds will be, just replace x here with 1. So you will get beta naught plus beta 1. Then odds for non-smoker, we replace x with 0. So you akan dapat beta naught. So the difference between this odd, we can find the odd ratio to see dia punya difference, how many difference and so on. So kita boleh kira dia punya odd ratio. Odd of smokers divide dengan odd of non-smokers. So it will be here e power of beta 1. Okay, for example, from the output of SPSS, so when we construct the logistic regression analysis from the SPSS, we will have one of these output, which is the output for the coefficient of the logistic regression model. So from here we can see that this is the this column B adalah dia punya coefficient, and then yang kita nak fokus sekarang adalah this column B adalah dia punya coefficient, and column of exponent beta. Okay, ini adalah nilai odd ratio. Okay, so from this output we can write the logistic regression model. So kita boleh tulis macam ni lah, ln P over 1 minus P, okay, equal to dia punya beta naught adalah negative 0.405 plus 1.792 smoker, which is our X. So this is our logistic regression model. Later we can check whether this model that we create here can be used or not. Okay. Alright. So we can find the odd ratio. Okay. The odd ratio, it will be macam tadi kan, e power of beta 1. So e beta 1 adalah 1.792. So you akan dapat 6 here. Ataupun from the output actually we can have the value of odd ratio for smoker, which is 6. Terus ambil daripada output here. Okay, exponent beta tu adalah nilai odd ratio for smoker and non-smoker will be 6. So how to interpret this odd ratio? So usually untuk logistic regression, we not interpret this coefficient beta 1, but we interpret the odd ratio for that x, which is this one, 6. So we can interpret the value of 6, which is the odd ratio. We also can find the value of 6 tadi, gunakan ini tadi kan, e power of beta, e power of the coefficient for the variables. So you akan dapat 6. Okay, so how to interpret this? Because of X adalah kategori variable. Okay, tadi kan 1 for smoker, 0 for non-smoker. So it indicates that a smoker, which is that we coded 1, a smoker, is 6 times more likely to develop the lung cancer, which is our interest study, why that we coded 1, okay, develop the lung cancer, compared to a non-smoker. Okay, a smoker is 6 times more likely to develop a lung cancer compared to a non-smoker. Here smoker, because of we coded 1, kalau tadi kita coded 1 as a non-smoker, so ia akan jadi indicates that a non-smoker is 6 times more likely to develop lung cancer sebab kita coded Y1 tadi sebagai develop lung cancer, which is our interest, okay, our variable of interest compared to a smoker. Kalau kita tukar tadi lah, kalau 1 tu sebagai non-smoker, 0 sebagai smoker. Okay, so you kena tengok betul-betul lah when you want to interpret. You need to see whether the coded 1 to which category. Okay, that is the way how we interpret the coefficient of the logistic regression model. Okay, using the odds ratio. We also can find the value of probability. Okay, macam tadi kan, we have this model, dipanggil logistic regression model. From this model, we have the nilai the coefficient P here, but actually we can calculate the value of P. Okay, we can calculate the probability of getting lung cancer if a person is a smoker. Okay, which is using the previous formula, like I said just now, it will be 1 over 1 plus e power of negative beta naught plus beta 1 x. So here kita replace x as 1. Kenapa? Sebab kita nak tahu probability a smoker getting a lung cancer. So tadi x equal to 1 adalah smoker. So you will replace here x with 1. So you akan dapat probability of a person getting a lung cancer if that person is a smoker is 0.8001. We also can find the probability of getting lung cancer if a person is a non-smoker. Okay, is a non-smoker. Gantikan x here with 0. Okay, you akan dapat the probability of a non-smoker will get the lung cancer. Okay, ataupun it just 1 minus the value of 0.8001. Okay. Alright, that is the regression model. But actually, to proceed with the regression, the logistic regression model ataupun the logistic regression analysis, first of all, you need to check the assumption of the Hosmer dan juga walk test. But for that one, I akan explain dalam lab nanti, dalam lab session nanti. Okay. Okay. So tadi you dah tahu how to interpret the coefficient using the odds ratio, how to develop the model, the logistic model. And the next one, we also can use the model, the logistic model, to classify the new random variable. Okay, the new observation. We classify to which groups of y. Okay, let the response variable y be 1 if the observational unit belong to population 1, okay, and 0 if it belong to the population 2. Dan kita ada dua kan, the first group and the second group. Okay, we coded y1 as the first group and we coded y equal to 0 for the second groups. Okay, we will assign the new observation X to the population 1 if the estimated odds ratio. Kenapa population 1? Sebab kita punya interest adalah that we coded Y equal to 1. Okay, we assign the new observation to the population 1 if the estimated odds ratio is greater than 1. Estimated odds ratio. When we find here the exponent power of beta naught plus beta 1 x1 plus beta 2 x2 until beta k as k. Okay, it depends how many independent variable that we have. If we calculate the exponent ataupun dipanggil the odds ratio, okay, when we replace all the x, then we get the value is more than 1. So we will assign that new observation to the population 1. Okay, if less than 1, we will assign that new observation to the second population. Ataupun kita boleh gunakan the model, the function of logistic, kan? This one, the function. If the value, when we replace all the x and beta that we know, bila value-nya more than 0, so we can assign the new observation to the first population. If less than 0, we assign it as to the second population. So ada dua cara, sama ada gunakan odds ratio, exponent power of the function, ataupun boleh gunakan a logistic function itself. Okay, more than 1 and more than 0. Okay, for example, using the same example of the lung cancer just now, kita punya Y adalah develop lung cancer, Y equal to 1, Y equal to 0, not develop a lung cancer. And then kita punya variable adalah X1 if the person is smoker, X0 if the person is a non-smoker. Then we have this output. From here we can have the regression function, the logistic regression function. Dia punya coefficient here. Okay, so sekarang we want to know Ali will be put ataupun classify into which group of Y. Okay, by, ada dua cara. First of all, kita just masukkan, kan, replace here X equal to 1 because Ali is a smoker. Okay, we replace here X equal to 1, but we have the information Ali is a smoker. Okay, this is the logistic regression model tadi, kan? We replace X equal to 1, so you will get 1.387. Okay, when 1.387, macam mana tadi? Okay, bila when we replace all the X into the function, the estimated function of the logistic, when we get more than 0, so we will assign that individu, that person ataupun that observation tadi to the first group. Kan, maksudnya kita classify with the group of develop a lung cancer. Satu cara gunakan function. Satu cara lagi kita boleh gunakan juga exponent ni ataupun the odds ratio ni, kan tadi, exponent of the logistic function. Okay, exponent power of 1.387 here. Okay, we will get 4.002, which is greater than 1. So Ali is assigned to the population 1, which is the develop a lung cancer. So because of Ali is a smoker, and we when we do the classification, we can say that Ali will be classified as a first population, which is the person that maybe will develop a lung cancer. Okay, the next one is model assessment. Okay, before this, dalam discriminant analysis pun, we have the model assessment. We can measure the performance of the discriminant analysis using the classification table, right? So sama juga, using the logistic regression, we also can measure the performance of the logistic regression using the classification table. Cuma maybe the classification table-nya berbeza sedikit lah dia punya dari segi the arrangement of the value-nya. Okay, so to know the misclassification rate, macam biasa sebenarnya misclassification rate, kita akan tengok the value of misclassify, which is here 2 and 1, right? 2 and 1, 2 plus 1, 3, divide dengan total of the observation, which is 10. You akan dapat 30%. 30% of misclassification. Itu cara nak kira. Macam sebelum ni kan, total of misclassification divide dengan total of observation. So you akan dapat 30%. Ataupun daripada classification table ni, kita boleh terus dapat kat sini adalah percentage, overall percentage that will give the good prediction, which is just 70%. So 70% adalah classification rate. So misclassification rate will be 100 minus 70, will get 30. Okay, ada dua cara lah. Sama ada you boleh calculate the misclassification 2 plus 1 divide dengan 10, ataupun 100 minus dengan 70. So macam mana how can we know whether this regression function is will give the good prediction or not? Okay, if the overall percentage here is greater than 80%, the model will have a good prediction. So for this example, since the overall percentage is only 70%, okay, so we can say that the model does not have a good prediction, and the misclassification rate is also 30% kan. So okay, as you know, if the misclassification rate is less than 20%, so we can say that the logistic regression function or the discriminant analysis will give a good prediction if it is less than 20%. Okay, if it is more than 20%, the regression function, the logistic regression function, will not give the good prediction. Okay, that's all.